I'm Karuturi and I'm representing Illinois. My project was on how chemical speciation of zinc controls biouptake by microorganisms through absorption. So the guiding question of my experiment was how do metals bind to microorganisms and what is their general binding affinity? Before I get to the process of my investigation, let me talk about the connection it has to water quality. It is no secret that industrialization has left much of the world's natural habitats, specifically aquatic ones, contaminated with various metals. To restore these habitats, there needs to be an understanding of how metals interact with their environment, especially since it has been noted that certain microbes essentially flourish in metal-contaminated habitats. So if we understand how microbes and metals interact, we can develop a way of removing the contaminants sustainably. So as for my investigation, I had two main experiments going on. For the first experiment, I extracted the microorganism E. coli from a petri dish and grew it. I made two solutions, a lysogenic broth and a minimum salt medium. The E. coli grew in the lysogenic broth and was later suspended in the minimum salt medium. After the E. coli reached an optical density of 610 nanometers, it was exposed to a 0.02 molar metal solution to assess if this microorganism was able to uptake it. Secondly, zinc absorption experiments were performed using three solids, TiO2 and two different hydrated silica particulate matte materials. The purpose of this experiment was to determine the surface absorption of zinc that controls its biouptake. 1 liter of zinc solution was prepared by adding 0.2 milliliters of a MOPS buffer, 0.1 milliliter of potassium nitrate, and 4 milliliters of sodium hydroxide. The rest of the solution was filled with deionized water. For the solids, about 0.04 of silica A and B were added respectively and put in a 40 milliliters silica stock solution. For the TiO2, 40.5 milligrams was added in a zinc stock solution with zinc nitrate. The samples that had a solid were centrifuged, filtered, and finally acidified with nitric acid in 10 milliliter tubes. 20 total samples were prepared, 10 samples with solid and 10 without. The purpose of this was to compare by subtraction how much metal bound to the surface of a tube and how much bound to the solid. The tubes prepared with different solution from the buffers and silica were left for 24 hours and centrifuged in different concentrations of zinc. The amount of zinc in solution was determined by flame atomic absorption spectroscopy. Solutions were aspirated in the flame by placing a tube connected to the burner inside the 10 previously prepared standards. The spectrometer detected zinc after its atomization in a flame and provided the concentration of zinc in part per billion. For results, in the zinc absorption of 1 gram per liter of TiO2 and silica A, there was a negative correlation between percentage of zinc absorbed and millimolar of zinc added, as well as an exponential-like increase when recording the equilibrium point. Additionally, the Browner-Emmett-Teller method concluded that silica samples had a greater specific surface than TiO2 particles did, yet TiO2 had a greater active site density. In the future, I hope to conduct more experiments to solidify the constants I gained from this one. Thank you.